Hello everyone, and thank you so much for joining me today. My name is Vennam, and I'm an offering manager on IBM Cloud. You may also recognize me from some of the videos that I create on YouTube, and that's another part of my role here at IBM is working with customers, users, and viewers like you to make sure you're equipped with the knowledge you need. Today, we're going to be talking about hybrid cloud in an open world. And I also want to give us a little sneak peek into some of the things that we've been working on in IBM Cloud to help you in your journey, wherever you may be, in that hybrid cloud. Now, I want to start with this graphic. It's a number and a figure that I'm sure many of you have heard from IBM in the past before, but it's the idea that 20% of assets have already achieved, enterprise maturity on a public cloud. And traditionally, we see those applications as, greenfield apps or newer cloud-native applications that maybe aren't so tied back by legacy requirements. But the piece that's remaining to be unlocked is, the hidden part of the iceberg. This is the piece that requires customers and users to really embrace and truly use hybrid cloud platforms. But we understand that there's limitations and issues that are preventing customers from making these adoptions. These days we've got to concern ourselves with things like security. We've got to concern ourselves with things like consistency of operations and development across the board. With more environments does arise more problems. But we believe that in IBM Cloud, we've created a multi-cloud platform architecture and strategy to help you be successful in that transformation. So what is that basis based on? Well, for one, our hybrid multi-cloud platform can run on infrastructure anywhere, whether it's on-premises, on IBM's public cloud, a private cloud, or even competitor clouds. And we've got some really interesting capabilities that I'll talk about a little bit later in the presentation that enable exactly this, and that's using IBM services anywhere. On top of that infrastructure, we've got a foundation based on Red Hat OpenShift. Now, with that acquisition of Red Hat, we've been working more and more together, and they've got just an amazing, stellar container-based platform that is OpenShift. Being able to orchestrate containers at an enterprise level with the security you expect from IBM and Red Hat is made possible through OpenShift. It's essentially Kubernetes for the enterprise. Now, on top of that layer, we've got certified offerings here, Cloud Paks, which, to put it simply, it's all of the organizations within IBM. We've had capabilities in the integration portfolio, in the automation portfolio. We've re-architected and made sure that they work on container-based platforms. That means you can run all of these, IBM capabilities that you know and love, as well as new capabilities that these teams have been working hard to put out, but now in a cloud-native consumption format. They're now available through Kubernetes-based platforms, specifically running on Red Hat OpenShift. And with this hybrid multi-cloud platform, we really do think that our customers are equipped to make the steps forward. But let's take a step back and talk about what a traditional hybrid cloud was considered to be, right? So these are the kind of fundamental capabilities of a hybrid cloud, and that's going to be, locations from multiple different vendors. That's on-premises, public cloud, edge environments, as well as public cloud. Now, in a traditional hybrid cloud, if someone were to come to you 5 years ago and say, how would you approach hybrid cloud? Well, you would have different applications and legacy apps and cloud native apps running in different environments, but there arises a very pressing problem, and that is the lack of consistency. With multiple cloud environments, you gain multiple challenges, and the overall theme here is inconsistency. Now, with the traditional hybrid cloud, you'll have inconsistent development ops workflows, obviously, right? Because the workflows to work with SoftLayer on-prem might be different than working with IBM public cloud. So your ops teams have to be able to manage multiple different environments, and your dev teams have to be able to manage multiple deployment environments. Let's take that a step further. Inconsistent consumption of content. Now, in the public cloud, we always say we've got the latest and greatest cloud native capabilities, from databases to even more advanced things like artificial intelligence and machine learning and more. But say you wanted to consume those things in a secure, efficient way on premise. How would you deploy a public cloud service on premise? Well, now you have to start thinking outside of the box. Maybe you do a custom deployment. The fact is, it's not seamless and there's some inconsistencies there. Now, with security and compliance controls, you have the same issue, pushing out regulatory and compliance controls across the board, as well as observability, visibility, and management. So I talk about these challenges because, these are things that were a problem, 5 years ago. And this generally was the way that anyone would address and start working towards hybrid cloud, is to start tackling these problems. And I can confidently say that there are technologies in IBM Cloud that help you tackle these issues, piece by piece. But I think what I am really excited for is the concept of distributed cloud. And distributed cloud takes hybrid cloud to the next level. In fact, I'd argue that distributed cloud fixes what hybrid cloud breaks. Now, we've talked about the challenges with hybrid cloud, and we've talked about the issues that it presents to users today, and how the landscape of the ecosystem of solutions and capabilities out there today help you address issues with hybrid cloud. But I think the one leader in the space that we're going to have to start looking out for is this concept of distributed cloud. I think it really does tackle the nail on the head here with the challenges that are essentially plaguing traditional hybrid cloud deployments. Now we saw that initial figure, right? That only 20% have made it onto a true hybrid multi-cloud, cloud native approach. Now that remaining 80%, I truly believe that a distributed cloud offering can help you really crack at that percentages and really break those down and start migrating some of these things to cloud native. So what exactly is a distributed cloud? Well, it refers to the distribution of cloud services onto the different physical locations that you may want to run them. But here's the key bit. The responsibility of maintaining that service, the governance, the operations, still lies on the cloud provider. Let me put this a different way. This is referring to the availability of services that were previously only ever available on a public cloud data center. These services are now available to run anywhere. That's the idea of distributed cloud. Now, let's break that down a little bit further. But first, I want to say, I'd love for you guys to take a look at what we're doing with IBM Cloud Satellite, which is essentially our offering, our distributed cloud offering, and it's essentially IBM Cloud anywhere you need it. Now, there's not really any gimmick. If anything, the one catch is that you need to have Linux-based infrastructure, and then IBM will do the rest. That's really it. And the idea here is, as long as there's Linux compute that you register with IBM Cloud Satellite, we're going to be able to deploy IBM Cloud services directly on those platforms. Here's what that looks like. For IBM Cloud Satellite, you can run hosts anywhere. That includes existing infrastructure. You can use IBM's public cloud, maybe a turnkey appliance on premise maybe, and as well as edge computing nodes. And here's the key bit, even other public clouds. Now the idea is that what we'll do on each of those individual hosts is install basically a little module that enables IBM Cloud to connect with that and with that environment. Now that environment link is established by something we're calling satellite link. Now with that link, essentially what that enables us to do is deploy IBM's public cloud services onto those environments. And that includes, the foundational layer, which is going to be Red Hat OpenShift. That's where you're able to run applications, capabilities directly on top of OpenShift. That's the kind of core to the functionality that we're exposing here. It's the ability to spin up clusters on your compute, but let us handle the heavy lifting when it comes to things like security patching, upgrades, configuration management, security and compliance kind of pushing those modules out, and just all of the requirements that previously plague ownership of traditional on-premise platforms. We'll handle those responsibilities. You just tell us, you come to the IBM public cloud and say, I want a cluster on my on-prem data center in Phoenix and Morocco or wherever it might be, and we'll spin it up for you. We'll manage that heavy lifting. Now, take that a step further. It's not just OpenShift that you guys want at the end of the day, which is kind of a platform as a service. You're also going to want services to consume things like databases and cloud packs. All of those will be available, are available through IBM Cloud Satellite to deploy onto an environment of your choice. Now, today, IBM Cloud Satellite is in beta. We're planning to release early next year. Now, IBM Cloud Satellite is kind of our premier distributed cloud offering, so I'd say keep an eye out for it, but it's core to the hybrid multi-cloud strategy that we're pushing forward in 2020, 2021, and moving forward. At the end of the day, a traditional hybrid multi-cloud environment can struggle due to the inconsistency of experiences across the board, the inconsistencies we talked about with development operation workflows, consumption of content, security and compliance controls. These are all handled by Satellite as they give your developers and ops teams a single dashboard within IBM Cloud to be able to manage environments anywhere, even if they're running outside of IBM Cloud. Now, let's take a look at an example of exactly what this looks like by kind of investigating something with distributed analytics. Now, in this particular example, let's say that you're running in multiple environments here, right? On the top right, we've got an on-premises environment. On the bottom right, we've got edge environments. And let's say that you've also got a number of different environments on other public clouds potentially. Now, say you want to use something like Cloud Pak for Data as a source to feed all of the analytics and data coming in, and maybe use artificial intelligence to basically identify issues, ensure integrity, and that kind of thing. So in this particular model, what we're doing is deploying consistent kind of databases, analytics, as well as management capabilities across the board here. So you'll see that, what were previously only IBM Cloud-based services, you can now deploy on-premises, such as a PostgreSQL, on an on-premise location, as well as an edge location. So now you have consistency where the data is being created to be able to collect that data. Now, using Secure Link, we're able to kind of transmit those analytics pieces and data directly to Cloud Pak for Data running on OpenShift and IBM Cloud. This enables a client to kind of essentially have a central place where all of their data is governed, and in addition, use artificial intelligence and specifically AI ops to do things like ensuring, maybe a model integrity for something like a machine learning model before doing a distributed deployment across the board. So this is a simple example, but it shows you how you can really create a consistent experience for analytics across the board by deploying consistent IBM Cloud services to any environment. I'd say that this is core to the capability of our new hybrid multi-cloud. So now that we come back to this platform diagram, it starts to kind of come together. Your infrastructure can be running anywhere, but at the core of it with IBM Cloud Satellite, IBM Public Cloud can be your central governance hub for these environments. On top of that, we've got key certified offerings that enable you to tackle use case specific issues, whether it's data and AI, whether it's integration for things like API management, whether it's automation for business processes, a capability is available there. Now, one key thing that I do want to point out here, because it is a common question. Now, the question is, say, the link with IBM Cloud broke down, would my applications fail? And the answer is no. On your environments that you deploy, your on-prem environments that you're deploying, even if they lose complete connectivity to IBM Public Cloud, they continue to run as expected. What Satellite is doing is exposing those data for your operations teams and your development teams to have a central governance on IBM Cloud. But there's no net latency or network hop or anything that happens between IBM Cloud and your edge environments for running applications. Your applications continue to run even without communicating back to IBM Public Cloud. That being said, I just want to let you guys know here, we've been working very closely with leading financial institutions around the world today, and we think that our strategy is setting ourselves up for success moving into the future here. I do truly believe that the strategy that we're taking with distributed cloud and IBM Cloud is something that will be recognized, and we're seeing that already with BNPP. They're able to innovate faster and provide better customer experiences. I want to thank you all so much for joining me today for this presentation on hybrid cloud in an open world. I hope you found this useful. If you want to learn more about some of the concepts I talked about today, or maybe you want to learn more about things like Kubernetes or OpenShift, or even things like Satellite, be sure to check out youtube.com/IBM Cloud, where we do regularly post and update videos. Thank you again so much.
Hi everyone, my name is Vennam with the IBM Cloud team. Today, let's talk about Red Hat OpenShift on IBM Cloud. First, OpenShift. It's an open source application platform that aims to make the Kubernetes experience better for developers and operations teams. Red Hat OpenShift on IBM Cloud is a fully managed platform from the ground up. This has a number of advantages which we'll cover in this video. It starts with an integrated OpenShift experience. You'll get automated provisioning of the infrastructure as well as configuring OpenShift. You can take advantage of features for high availability to ensure your applications will never have any downtime. And finally, for all of your monitoring and logging needs, take advantage of direct integrations with Sysdig and LogDNA. Let's get started by walking through the process of creating an OpenShift cluster. We'll navigate through the dashboard and choose an OpenShift cluster. We see some information about this service, and we'll go ahead and hit Create. Now we're asked to provide some information to start creating this cluster. We see an option to choose between Kubernetes or OpenShift. So we can go with native Kubernetes, but in this example, we'll be working with managed OpenShift on IBM Cloud. So by choosing OpenShift, we can then scroll down and choose a number of different geographies. We have multi-zone regions worldwide, which enable you to have highly available clusters spread across multiple data centers in the same region. Next, we have choices for the default worker pool. We can take advantage of either shared or dedicated virtual compute. In addition, there's options for bare metal and GPU-enabled machines as well. Finally, we'll choose the number of workers that we want, and we'll go ahead and provision that cluster. The cluster will be ready shortly, but in the meantime, let's go ahead and jump to a cluster that's already started. Let's see the IBM Cloud console experience. We can see a basic overview of our cluster. We can set up something like Key Protect, an encryption key management service to encrypt your applications and data, and this even supports bringing your own key. Switching to the other tabs, you can fully configure the workers your cluster is using. This includes updating your worker nodes, as well as configuring additional worker pools. Let's get to the good stuff, the OpenShift Web Console. Here we have the OpenShift Container Platform Web Console. We can first start by creating a project. A project is an OpenShift abstraction based on namespaces, but it has user management built in. This means you get the best practices for security from the start. With a project, we can start by navigating the catalog or importing an existing project. Let's start by browsing the catalog and choosing a Node.js application which comes with a Mongo database attached. We'll go ahead and choose the default configuration options and hit Create. Within minutes, it starts to provision our application, the database, the access, and even sets up some routes for us. This build is going to take a couple of minutes, so let's go ahead and switch to a project where I've already got this application running. Well, we have a deployment, but the first thing I want to do is actually enable access to it. We'll go into the Routes view and create a new route. we'll go ahead and make sure that it's connected up to the right service and hit create. Let's test that it works. We'll go into our routes and hit that host name. And there we go. We can access our Node.js application running in OpenShift. The OpenShift web console makes it easy for day one tasks, like building and configuring applications. For day two operations tasks, we'll want to take advantage of the OpenShift CLI. Let's take a look at the CLI experience with the OC commands. After installing the CLI, we'll grab the login command from the OpenShift web console. We'll then open up a terminal and paste that same login command. In a few seconds, it will log us into the cluster, and we can get started by first running the OC project and then putting in the name of the project that we just created. We can run some environment health checks here and verify our running pods and containers. Let's start by running the OC get nodes command. This is going to allow us to see the different worker nodes and the hosts that are running within our cluster. Now, let's see the pods that are running in our application. We can run the OC get pods command with the -o wide parameter. This is going to allow us to see our running pods as well as the node that they're running in. You can take advantage of integrations with Sysdig and LogDNA. By accessing the observability dashboard on IBM Cloud, you get access to all of this in a single location. Here, you can access your logs with LogDNA and gain rich container visibility using Sysdig. From its onset, Red Hat OpenShift has been focused on making the Kubernetes experience easier and enabling enterprises to take on cloud-native development. IBM Cloud builds on open source for advanced capabilities to ease the pain of security and scale, not just on day one building, but also day two operations and across the lifecycle of the software. Together, IBM and Red Hat are building an open hybrid cloud foundation built on open source technologies and principles to allow you to get started on your hybrid cloud strategy the right way.